Hello students, how are you? Welcome to my virtual class. Today's lesson is latent heat and effect of change of pressure and evaporation. So first we see latent heat. Students, you know when heat is given to a substance, its temperature increases. However, when heat is supplied to change the physical state of a substance, there is no increase in temperature of the substance. This heat is called latent heat. The heat energy which has to be supplied to change the state of a substance is called latent heat. Since it does not rise the temperature, it is called hidden. It cannot be detected by thermometers. Okay. Latent heat is of two types: latent heat of fusion or latent heat to change the solid state to liquid state. Secondly, latent heat of vaporization, that is heat required to change the state from liquid to gas. Now I would try to explain with a graphical representation. See, here the heat is plotted along the x-axis and temperature along the y-axis. You know, when heat is supplied to a solid, its temperature will be rising. Okay, temperature rises as we continue to supply heat. At this point, beyond this point, when we supply heat, the temperature remains constant or fixed, that is, does not rise. But we are constantly supplying heat, and the solid substance from this point is started fusing, that is melting. Okay, it is melting, and at to this point all the solid melted into liquid state. But the energy given from this point to this point is called latent heat of fusion. Okay, now again, if we supply heat to the liquid, the temperature of the liquid increases. At this point again, temperature of the liquid remain fixed, unchanged, until all the liquid changes into gas. But we are supplying heat continuously. From this point to this point, this much amount of heat is called latent heat of vaporization. That is, this much heat is used to change the state of the matter, that is from liquid to gas. This temperature is hidden and does not show in thermometers. Okay, next we see latent heat of fusion. Latent heat of fusion, the amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point, is known as latent heat of fusion. First of all, the solid is to attain the temperature, that is its melting point. Beyond that point, the heat energy supplied to the solid is used to change the solid into liquid, and temperature does not rise. This heat is called latent heat of fusion. Okay, for example, latent heat of fusion of ice is 334 into 10 to the power 5 joule. That is, at 0 degree C we need 3.34 into 10 to the power 5 joule of energy to melt per kg ice into water. Okay. Now we see the latent heat of vaporization. The amount of heat energy that is required to change 1 kg of a liquid at its boiling point into gas without rise in temperature is known as latent heat of vaporization. Okay. For liquid, first we have to take the liquid at its boiling point. Beyond this point, the energy supplied to the liquid is used to change the state of the matter, that is liquid to gas, and temperature does not rise, and that until all the liquid changes into gas. Okay. After all the liquid changes into gas, then temperature again rises. Okay. But in between the boiling point and conversion of all the liquid into gas, the heat used is called latent heat of vaporization, and it does not change the temperature. For example, latent heat of vaporization of water is 22.5 into 10 to the power 5 joule. That is, at 100 degrees C or 373 K, 1 kg of water, to convert 1 kg of water into steam, we need 22.5 into 10 to the power 5 joule energy. So we see the particles in steam, that is water vapor, at 100 degrees C or 373 K have more energy than water at the same temperature. And in this case also, the particles in water at 0 degrees C at the same temperature has more energy than particle of ice at the same temperature. Okay. One practical one example is that we notice that burns caused by steam much more severe than those caused by boiling water, though both of them are at the same temperature, that is 100 degrees C. Okay. Why this happened? This is because as particles in steam have absorbed extra energy in the form of latent heat of vaporization. We know that steam has an extra energy in the form of latent heat. Thus, when steam falls on our skin and condenses to produce water, it gives out 22.5 into 10 to the power 5 joule per kg more energy than boiling water. That is why steam causes more severe burn than boiling water at the same temperature. Okay. So now we see the effect of change of pressure. An increase in pressure brings the particles closer and increases the force of attraction between them. That brings about the change. That is, when high pressure is applied to a gas and its temperature is reduced, the gas is converted into liquid. Okay. The physical state of a substance can also be changed by changing the pressure. Okay. Let us see this diagram. A gas is kept in the cylinder with piston. Okay. Now if we increase the pressure, the gas will be compressed. Since we know that gas is compressible substance, it is compressed, and this gas is called compressed gas. If we further increase the pressure, the gas may be liquefied. Okay. So we see, by applying pressure or changing pressure, we can change the state of the matter, that is from gas to liquid. This is called effect of change of pressure. Okay. By applying pressure and reducing temperature, we can liquefy gases. For liquefaction of gases, there are two conditions. One is reducing temperature and another is applying pressure. When we apply pressure, the gas particles come closer and closer and closer, and interparticle attraction becomes higher. At certain pressure, the gas becomes liquid. Okay. Thus, pressure and temperature determines the state of a substance. Okay. No substance is absolutely, we cannot determine the state of the or express the state of the substance absolutely. For example, wax. Wax is a solid. Okay. But it is solid under normal temperature and pressure. If we heat it around 60 to 70 degree, it will be melted. It will be liquid. Okay. For example, ice, water is liquid, we all know, but in the Greenland or Antarctica, the water is solid. Okay. Therefore, the state of the matter determines by the pressure and temperature. Okay. The pressure of air in atmosphere is called atmospheric pressure. That is, air above the surface uh, exert pressure on the substances. This is called atmospheric pressure. Okay. The atmospheric pressure at the sea level is taken as 1 atm. To express the normal pressure that is at sea level, we use 1 atmosphere, that is 1 atm. 1 atm is equal to 760 mmHg. Okay. Depending upon the height from the sea level, the pressure is changing. As we go above the sea level, the pressure decreases. Okay. So next we go to the another term, it is evaporation. The process of conversion of liquid into its vapor state at any temperature below its boiling point is called evaporation. Okay. We know particles of matter are always in a state of random motion. This is also true for liquid. Okay. The particles of a liquid have different amount of kinetic energies. The particles present at the surface possesses comparatively higher kinetic energy to those present in the bulk, that is inside the liquid. Therefore, particles at the surface with higher kinetic energy is able to break away from the force of attraction of other particles and get converted into vapor. Water, when left uncovered, slowly changes into vapor. For example, wet clothes dry up or happen due to evaporation. This is the example of evaporation. This is also example of evaporation. Evaporation is also by evaporation, the matter or substance is also changing the state, that is from liquid to gaseous state. But the process is very slow and it occur well below its boiling point. So it is called evaporation. Okay. Here drying wet clothes is also evaporation. Okay. The reason already discussed. Particles of liquid matter are always in a random motion. One. Secondly, the particles at the surface possesses higher kinetic energy and is able to break away from the force of attraction of other particles. This is a diagram to represent the kinetic energy of the surface area. Particles in the surface area. Particles in the surface area are have more kinetic energy. Therefore, they can break away the attraction of other particles and move to the gaseous phase. Okay. The particles with higher kinetic energy leaves the liquid surface. and in the bulk, the particles in the bulk have lower kinetic energy. Okay. Next, we see factors affecting evaporation. Firstly, surface area. Okay. The rate of evaporation increases on increasing the surface area of the liquid. Evaporation is a surface phenomena. It occurs on the surface. Okay. If the surface area is increased, the rate of evaporation increases. For example, while putting cloths for drying up, we spread out them. Okay. So evaporation is a surface area. To cool down a hot tea, we put the tea from the cup to the plate, because to increase the surface area, it is uh, cool down quickly. Okay, evaporation occurs very rapidly. Next, temperature. The rate of evaporation of a liquid increases with rise in temperature. With increase in temperature, more number of particles get enough kinetic energy to go into the vapor state. That is why evaporation is faster in hot summer day than in winter or a cloudy day. You see, uh, from hot water or hot cup of tea, the evaporation is going on faster rate. Because all particles have higher energy, and on the surface, the particle on the surface is uh, have more kinetic energy. Okay. Next, humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, okay, the rate of evaporation decreases. This is why clothes dry up faster in dry day than on a wet rainy day. Okay. So if already there is more water vapor or humidity in air, the evaporation takes place slowly. Okay. This is the example. Next is wind speed. It is known that clothes dry faster on a windy day. This is because with increase in wind speed, the particles of water vapor move away with wind, decreasing the amount of water vapor in the surrounding. Okay. That is why rate of evaporation of liquid increases with increasing wind speed. Okay. When we want to dry up clothes in the night, we use the fan. We switch on the fan to dry up clothes, and when we clean our floor, wipe our floor with water, we switch on the fan to dry up very quickly. This is due to the wind speed. Wind take away the water vapor close to the water layer and speed up the evaporation. Okay. The liquids which evaporate fast are called volatile liquids. Overall, the evaporation is depend on the particle interparticle attraction between the liquid molecules. The molecules which have the liquids which have very low interparticle attraction evaporates very easily or quickly. These are called volatile liquids. For example, uh, if we compare water and ethanol, that is spirit, the attraction between water molecule and attraction between the spirit molecule are not same. The attraction between the spirit molecule are lower. That why spirit evaporates very faster. Okay. Next, we see evaporation causes cooling effect. When ice cold water is kept in a glass for some time, water droplets are observed on its outer surface. This is a common phenomenon. All of you have noticed this. If you take out some cold water or cold drinks from fridge and keep it for some time in open air, the few droplets over the surface we noticed. This occurs as the water vapors present in the air come in contact of the glass or cold object. The water vapor get cooled and condensed to form these small water droplets. The formation of drops of water on the out surface of the container shows the presence of water vapor in air. If air contains more water vapor, then the droplets coming very easily. Okay, this is one example that water is vaporized at any temperature and remain in the atmosphere. Okay. Secondly, cotton clothes are used to wear during summer season. Okay. We know cotton clothes are very comfortable to wear in the summer season. This is because we know cotton is a good absorber of water. So it helps to absorb sweat from our body. As it is obvious, the person sweat more during the summer due to auto temperature control mechanism. This is a biomechanism of our body to cool down our body. Okay, sweating. Hence, wearing of cotton clothes helps in easy evaporation of sweat. It absorbs the sweat from our body and evaporates to the atmosphere. When this sweat evaporates, it takes latent heat of vaporization from our body or the clothes, which in turn cools the body. Okay, therefore a person feels comfortable. Okay. If we wear synthetic clothes, it does not absorb sweat from our body, and sweat is it is difficult for the water, that is sweat, to evaporate under the synthetic clothes. That why we feel uncomfortable and warm. Okay. Next, people sprinkle water on the roof or open ground in a hot sunny day. You may notice some people sprinkle water on the roof and on the floor to cool down the room on a hot summer day. When we spread or sprinkle some water on the rooftop, water gets evaporated very quickly. Okay. As evaporated water leaves the surface cool due to the large latent heat of vaporization of water, this technique is quite effective in summer for cooling the surface. Okay. The water take away the latent heat from the floor or from the roof, does it cool down the temperature of the room. Okay. Next, liquids like acetone, that is nail polish remover, present in nail polish remover, spirit, that is alcohol, when placed on our palm, we feel cold. This phenomenon you may have noticed. Okay, this is due to the fact that acetone and alcohol are volatile liquids. They get evaporated very easily. When we kept on palm, their particles gain energy from the palm, that is latent heat, or surroundings, and evaporate using that heat and causing the palm to feel cold. These liquids take away the latent heat of vaporization from our hand or skin. That is why we feel cold. Okay. So now we see difference between boiling and evaporation. Okay, boiling is also the process by which liquid is changing into gaseous state, and evaporation also the process in which liquid is changing into gaseous state. Okay, now we see the difference between these two processes. Boiling occurs at a particular temperature. For example, water boils at 100 degree centigrade. Okay. Evaporation occurs at any temperature below its melting point. Okay. Below its evaporation occurs any temperature below its boiling point. It should be boiling point. Okay, make the correction boiling point. That is, evaporation occurs at any temperature from 0 degree to 99.9 degree. That is below its boiling point. For example, water. But at 100 degree C, this process is called boiling, and below this 100 degree C, this is called evaporation. Boiling is a rapid process. The evaporation, the process of converting the state, occurs very rapidly, but evaporation is a slow process. Slowly liquid changes into gases. Okay, boiling is a bulk phenomenon. That is, boiling occurs from the all part of the liquid, surface, middle, lower, bottom, all part of the liquid. That is bulk phenomenon, all the from whole the bulk. Okay. Evaporation is a surface phenomenon. Evaporation occurs only from the surface. If we increase the surface area, the evaporation increases. If we reduce the surface area of water, evaporation reduces. Okay. Heat from external source required. To boil a liquid, we have to supply heat from external source. Liquid take heat from the surroundings. We need not supply heat. Okay. It is not necessary to supply heat. The liquid itself take the heat from the surroundings for the evaporation process. Okay. Temperature of the liquid remains fixed. During boiling, the temperature of the liquid remains fixed. That is, in case of water, the temperature is 100 degree C or 200, 373 degree, 73 K. Okay. Evaporation, temperature lowers. During evaporation, the vapors take away latent heat from the liquid itself, and the liquid gets lower its temperature. Okay, so these are the difference between boiling and evaporation. Okay, now you understand the topic discussed over here. From this with this discussion, we conclude the main topics of this chapter, that is matter in our surroundings. Okay, so after completion of this chapter, we are here in the question answer session and the homework. Now you have to answer these questions. Okay, how gases can be liquefied? What is the major factor which determines the state of matter? What is the SI unit of pressure? Give its value in ATM unit. By which physical process wet clothes dry up? Name the chemical compound present in nail polish remover. Which state of matter is responsible for the glow of the sun and stars? Suggest a method to liquefy atmospheric gases. How does the water kept in an earthen pot, that is kolshi, become cool during summer? Why does our palm feel cold when we put some acetone, petrol, or perfume on it? What type of clothes should we wear in summer, and why also? Why is ice at 273 K is more effective in cooling than water at the same temperature? What produces severe burns, boiling water or steam? What is meant by latent heat of vaporization? Why should wet clothes are sprayed while drying? Why perspiration keeps our body cool? These are the questions for your homework. First of all, you go through the lesson very carefully and then try to answer these questions. Okay. So, with this discussion, we have concluded our first chapter of class 9, that is matter in our surroundings. So, if you face any problem, you can contact me. So, until we start our next class, thank you to all of you for watching my class.